Hey mathematicians, let's do your homework. All right, we are combining like terms, which means that you're going to have to be boxing, underlining, doing something to separate these A's from these B's. So you can see I'm putting a circle around my A's and a rectangle around my B's. And nothing should be left out, which means that I need to circle not just that 5, but the negative sign in front of it. And I need to, rectangle is not a word, I need to draw a rectangle around not just the 10, but the negative sign in front of it. So if we start with our A's, we've got 2A and a negative 5A. If you want to draw a chart like this, you can. 2 and 5. Negative team wins by 5 minus 2 is 3. So we have a negative 3, and that's an A. And then we have our B's. We have positives and negatives. Positive 9B, negative 10B. This one is also a negative. 10 minus 9 is 1. This one is a little bit different, though, because I'm not actually going to write 1B or negative 1B, because when my coefficient is 1, I don't actually have to write the number. Because if I just say minus B, you know that means take away one of them. And then I'm going to circle or box my answer right there. When you have things like in number 2, we have x to the power of 4. And then we have x to the power of 2's. Oops, had to pause for announcements. Okay, so I have my negative, I have my x to the 4th power, and I have my x to the 2nd power. Those are different. So I cannot combine them, which is why I'm using 2 different symbols. This 9 is a negative 9x to the 2nd power, so they're going to get combined right there. So x to the 4th power has nothing to match with, nothing to combine. And then the x to the 2nd powers, I have, oops, not positive and positive, positive and negatives. I have negative 2 and I have negative 9. When they're on the same side, I actually add them. That makes negative 11. So I have negative 11 x to the power of 2. And there's my answer. So you're going to keep doing that on the front, and let's scroll to the back. It's been a really long time since I've made these. If my memory serves me, these should all be fraction problems. And I think it's a mix of like division, multiplication, adding, subtracting. Okay, the 8th grade students were given 45 minutes to complete 12 problems. Oh, I lied to you right now, because I can tell without even reading that problem. I just said 2 numbers and 2 different units. I think this is going to be a ratio problem. I think we're going to have 45 minutes and 12 problems. I'm going to read the rest of it just to find out. If they want to spend the same amount of time on each problem, how many minutes should they spend on each problem? Oh, okay, here's why it's in the fraction one, because you're writing your answer, your remainder will be fractional. So this is actually a rate, not a ratio, because a rate is for every 1. We want to know how much time they spend on every 1 problem. So to get from 12 to 1, we're going to divide by 12, which means that the actual math I'm doing here is 45 divided by 12. And then I'm going to have a remainder, but I don't want to put a decimal in there. I want to have a fraction as my remainder. Number 14, every can of Coca-Cola contains 9 2/3 teaspoons of sugar. That seems like a lot. How many teaspoons of sugar will be in a 6-pack of Coca-Cola? So a 6-pack is 6 times what the one of them has. So you're going to do 9 2/3 times 6. Remember that they both need to be fractions. Probably improper, but fractions, not mixed numbers, not whole numbers. Jonathan ran the mile in PE in 9.5 minutes. Jose ran the mile in PE in 8 2/3 minutes. How much faster was Jose than Jonathan? How much faster? That's a subtraction problem. I also might recommend, because we have not spent a lot of time subtracting fractions, you might want to actually change these to decimals, because it does not say that you need to have a fraction as your answer. If you're cool subtracting fractions, you need to change them to have common denominators. I'm looking at them and I'm thinking sixths. If you don't want to do that, then make this into a mixed number in decimal form. The only issue is that 8 2/3 will have a repeating decimal. So I'll say if you're going to do that, take it out to the hundreds place, and then we can approximate our answer from there. Last question. Woo! Mary has 6 2/3 cups of sugar in a bag in her pantry. She used 1/4 of the sugar to bake a cake for her friend's birthday. How much sugar did she use for the cake? 1/4 of the sugar. How much sugar? That much sugar. You are multiplying those two fractions / fraction times mixed number together. And now we're done with our homework. I hope you have a great weekend.